In this video, we will learn how fractional distillation separates crude oil into a useful oil. The crude oil, it is a term used to describe a processed oil. That this oil has been taken directly out of the ground, either on the land or under the sea. It is exceptionally valuable resources. It is provided with great numbers of the organic compounds, some of which used in the fuel and the other used in the manufactures of the many chemical and even plastic. However, it is a raw from the crude oil. It can be viscous, a dark colored tar, conceptually with the different fractions of hydrocarbon must be separated by fractional distillations for them to be used. Before we understand how fractional distillation works, we should be clear that crude oil is a mixture of the hydrocarbon with a different chain length. That means the numbers of the carbon atom, the carbon of the very long intermolecular forces and between the molecules. And the longer of the molecules are greater in the intermolecules, as you can see here. The small molecules have weaker intermolecular forces with they require less energy to break apart, and they have a low boiling point. The long molecules great intermolecules and the more energy, therefore a temperature. We will need to evaporate the molecules and the higher boiling points. Now we understand how chain length is related the boiling points of the molecules up to. Look you the mode and you can see crude oil is heated too. A high temperature outside of the fractional column. The hot crude oil now mostly is a vapor from the pumped into the column, and the column has a heat created in the very hot at the bottom color move up to the top, even the bottoms of the column where. The temperature is still high. Some longer chain molecules have a high boiling point, and it is packed to collected, and the bottoms of column. The rest of the molecules start to race up and the column making their way through a bubble cups in each tray. The bubble cups slow down and rate and rising vapor. Eventually the vapor and to cold condense and the collected tray. Small molecules have a low point. The small molecules have a low boiling point and so condense with the higher in the column. And the temperature is a color still, as you can see. A hydrocarbon with the similar boiling point are collected in the same tray, and the mixtures of the hydrocarbon with the similar boiling point. Each fractions is important. Use some example. For fractions, petrol used as fuel for cars, naphtha used in the manufactures of the chemicals and the fuel, kerosene or aircraft fuel. This oil, it is a used fuel for cars and lorries, and the butane mixtures of the large chain hydrocarbon with the road and on. In this video.